By referring to the formula of derivative, you might notice that the derivative of cosecant x is equal to negative cosecant x multiplied by cotangent x. In this video, we will discover how we can actually arrive at that answer using two different methods. Before we begin, let's recall that cosecant x is equivalent to 1 over sine x. So we can rewrite the equation by replacing the cosecant x with 1 over sine x. As now we have a quotient of functions, which is 1 divided by sine x, we can apply the quotient rule. Apart from that, notice that this 1 over sine x can also be written as sine x raised to the power of negative 1. As this is a composite function, we can apply the chain rule. Therefore, the two methods to differentiate cosecant x are the quotient rule and the chain rule. Now, let us begin by using the first method, which is the quotient rule. We first rewrite the equation as y equals 1 over sine x, just like what we did earlier. Here is the formula for the quotient rule. We let the numerator to be denoted as u, and the denominator to denoted as v. So we have u equals 1, and v equals sine x. Next, we want to find the derivative for both of them. For the derivative of u, which is denoted by u prime, it is equal to 0, as we know that the derivative of a constant is always 0. For v, we know that the derivative of sine x is equal to cosine x. Now, we have all the variables, and we can plug them into the formula for the quotient rule accordingly. For v, we have sine x, we plug it into the formula. For the derivative of u, which is u prime, we have 0. We repeat the same thing for the remaining u and v prime by substituting them into the formula accordingly. All we left to do now is to simplify this expression. For this sine x multiplied by 0, we'll just end up getting 0, so we can cancel it out from the expression. For this fraction, notice that we can actually split it into the product of negative 1 divided by sine x and cosine x divided by sine x. You see we have 1 over sine x, and we know that it is equivalent to cosecant x, so we replace the 1 over sine x as cosecant x. For cosine x divided by sine x, it is also the same as cotangent x, so we replace it into the expression as well. And we've got our final answer. That's how we find the derivative of cosecant x by using the quotient rule. Now, let us proceed to the second method, which is the chain rule. Just like what we did earlier, we replace the cosecant x as 1 over sine x. And this 1 over sine x is also equivalent to sine x raised to the power of negative 1. This is actually because of one of the rules of indices, where we have 1 over k raised to the power of positive x, it is equal to k raised to the power of negative x. That's why 1 over sine x can also be written as sine x raised to the power of negative 1. According to the chain rule, we first take the derivative of the outer function without changing the inner function. In this case, we can just apply the power rule, where we bring the exponent down and the new exponent is reduced by 1, but at the same time, we do not modify the inner function. Therefore, we get negative 1 multiplied by sine x, and the exponent has now become negative 2. By applying the chain rule, we will then have to multiply it by the derivative of the inner function, which in this case is the derivative of sine x, and we know that it is equal to cosine x. All we left to do now is to simplify this expression. For this particular part, which is sine x raised to the power of negative 2, we can rewrite it by using one of the rules of indices, which is similar to what we did earlier. In this case, we can rewrite this sine x raised to the power of negative 2 as 1 over sine x raised to the power of positive 2. Now, we multiply these expressions together and notice that we end up with the same fraction, just as we did in the previous method, where we can split it into negative 1 over sine x multiplied by cosine x divided by sine x. For 1 over sine x, we replace it with cosecant x. Lastly, for cosine x divided by sine x, we replace it with cotangent x. And we've got our final answer, which is exactly the same as what we obtained in the previous method. That's how we take the derivative of cosecant x by using both methods, the quotient rule and the chain rule. By comparing these methods, we can see that both approaches eventually lead us to the same answer, which is negative cosecant x multiplied by cotangent x. Hope you guys enjoy this video and find it helpful. Thanks for watching.